In this video, we're going to work some more on substitution and see some new kinds of problems to do. So starting with the first one, we see the inside function is going to be our natural log of x. So we will say u is the natural log of x. That makes du 1 over x dx. And solving for dx will give us x times du. So our integral is going to become u to the third, and when we replace the dx by x du, we can see that we will account for that extra x, and so our integral will become, we'll add 1 and multiply by the reciprocal, and then go back to our x's, so that's going to be 1/4, the natural log, and we can write the fourth power by putting it over the n, and that is going to be our indefinite integral. The next one, this is going to be a little trickier. We're going to try, it looks like u, the inside function, is going to be x plus 4, which is going to make du dx. So at our first try, we're going to call that the integral of 3x over, and that's going to be u to the second, and our dx is replaced by du. Now we got to figure out what to do with that 3x. So if we come back up to our u, we can say x is going to be u minus 4. So that means we can pull this 3 outside the integral and replace that x by u minus 4 all over u squared du. So now what we're going to do is separate that into u over u squared minus 4 over u squared times du. And then we can call that the integral of 1 over u, and that's going to be a minus 4u to the negative 2 du. So that will be the integral of 1 over u is going to be the natural log of the absolute value of u. And then we're going to add 1 to our exponent. We're going to multiply that by the reciprocal negative 1, which will make that negative 4 into positive 4 times that 3 is going to be a 12. And then finally, we'll go back to our x's. So that's going to be 3 times the natural log of x plus 4, and then a plus 2 times x plus 4 to the negative 1 plus c. Okie doke. Let me slide this up a little bit. So the next one, we're going to separate this and think of that as x to the third over x squared plus 7x squared over x squared minus 4 over x squared dx. So that's going to be just x, and that'll be a plus 7, and then we're going to think of that as an x to the negative 2 dx. So, whoops, we're ready to actually integrate. So that's going to be 1/2 x squared plus 7x. Then adding 1, we'll make that a negative 1. We'll multiply by the reciprocal, which is negative 1 times negative 4. We'll make that a plus 4. And there's our answer. The next one, we're going to say u is the denominator. Then du will be 2x dx, which will make dx be du over 2x. So we're going to get x on top. We're going to call the x squared plus 1 u. The dx will be replaced by du over 2x. We can cancel the x's, and let's, for practice, call that u of 0, u of 1. We can bring that 2 in the denominator all the way outside. U of 0 means we plug in 0 for x, making that lower limit 1. And plugging in 1 for the x makes the upper limit 2, and we have 1 over u du. So that's going to be 1/2 times the natural log of the absolute value of u, and we're going to evaluate that from 1 to 2. So that's going to be 1/2 natural log of 2 minus 1/2 natural log of 1, but the natural log of 1 is 0, so we can call that 1/2 natural log of 2. If we want, you could bring that 1/2 into the exponent, and 2 to the 1/2 would be square root of 2. So another version of that would be the natural log of the square root of 2. Either one's fine. Okay, on the next one, we can see the inside function is going to be u is going to equal 1 over x. And I'm going to need to change that because this needs to be an x squared. Good thing I have the power to do that. So that's going to be x to the negative 1. So its derivative, du, will be negative x to the negative 2. So the dx is going to be, to divide by that negative 2 exponent, we can bring it up, and it's going to be an x squared times du. So our dx is a negative x squared du. So our integral is going to become secant of u, tangent of u. We made that into an x squared so that our other x squared can cancel that. And so we'll pull the negative outside. So it's going to be a negative integral of secant u tangent u du. And remember, the integral of secant u tangent u is going to be secant of u. We got that extra negative. And then we can go back to our substitution, our x values, and that's our 1 over x, and then plus c. The next one, the inside function, is going to, we're going to do actually a double substitution here. So first, let's call that maybe u equals pi over 4x. You can do this in 1. Let's try, we can do it as 1. Let me make this different. Let's do it this way. Let's call this the integral of, well, we know the integral of tangent, so let's call this u equals pi over 4x. Du is going to be pi over 4 dx, so the dx is going to be 4 over pi du. So if you remember, this is going to become the integral of tangent of u du. This is one we need to know from memory. You may, at least in your head, think of that as being sine over cosine. And so if you make the denominator your u, the du is going to be a negative sign. So this is really a negative 1 over u du. So it's going to be a negative natural log of the absolute value of cosine of u plus c, which is a negative natural log of the absolute value of cosine of pi over 4x. Oops, I forgot the du part. Sorry about that. The du had that extra 4 over pi, so that's going to be negative 4 over pi. And so we are going to get, and then a plus c, or alternatively, because that negative could be brought into our logarithm as a negative 1 power, making that 1 over cosine, which would be a secant of pi over 4x. So either of these is going to be correct. Okay? So the next one, this one's tough. What we need to do is, let's go find a trig identity here involving a tangent. So if we divide by cosine squared x, because tangent squared is sine squared over cosine squared, then the sine squared over cosine squared is going to be a tangent squared, and the cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So we can replace that 1 plus tangent squared x with a secant squared x. So this is going to become the integral of the square root of secant squared x, but that's nice because the square root of secant squared x is going to be secant. Technically it would be the absolute value of secant x, but remember between 0 and pi over 3 everything's going to be positive, so we can call that just the integral from 0 to pi over 3 of secant x. This is a hard one to remember. We know the derivative of secant is secant tangent, so the integral is also going to have secants and tangents, but it's going to be the natural log of the absolute value of that. We're going to evaluate that, so now we have our challenge before us. Can we evaluate secant and tangent at pi over 3? And then we're going to subtract from that secant of 0 and tangent of 0. Okay, let's see. I'm going to come up here. Secant of pi over 3 is 1 over cosine pi over 3. Cosine of pi over 3 is 1/2, so that's going to be 2. So that's going to be the natural log of 2 plus. Now, a tangent of pi over 3 is going to be sine pi over 3 over cosine pi over 3. That's going to be a square root of 3 over 2 over 1/2, which is going to be a square root of 3. And so then we're going to subtract from that. Now the secant of 0 is 1 over cosine of 0. Cosine of 0 is 1. 1 over 1 is 1. Tangent of 0 is sine 0 over cosine 0, but sine 0 is 0, so that's going to make that be 0. So we're getting the natural log of 1, which is 0, making our final answer the natural log of 2 plus the square root of 3. And the absolute values are optional because that's not a negative number. Okay. Next one's kind of tricky, so we're going to say we're going to try making u the whole denominator, and let's see what that tells us about du. Well, it looks like it's going to be 2x minus 4 dx. At first glance we may think, uh-oh, that's not the same as the x minus 2, but if we factor that 2 out, we're going to be in business. So the dx is going to be du over 2 times x minus 2. So our integral is going to have that x minus 2. All of the denominator becomes u. The dx we're going to replace with du over 2 times x minus 2. We can cancel those. The extra 2 we can pull outside the integral as a 1/2, and this is hopefully a familiar integral. That's going to be our natural logarithm, and we'll go back to our x's, which was x squared minus 4x plus 3. Now we're going to look at another kind of problem. So if the degree of the numerator is greater than or equal to the degree of the denominator, we're going to need to long divide first. That is, we're going to have to divide the denominator into the numerator. So you can see on the first one that because we have the same degree in the numerator and denominator, we're going to take the denominator and divide that into the numerator. It may have been a while since you've done this, so let's refresh our memory. We're going to say, what times 2x squared is 2x squared, and that's going to be a 1. So we'll write down our 2x squared minus 3. We'll kind of line up our like terms. We're going to subtract this so that we'll get rid of the 2x squareds. The x will come straight down, and the minus negative 3 will cancel the other negative 3, and so this will be our remainder. We're going to take our remainder over what we divided by. So this quotient is equal to the original. So our integral now becomes 1 plus x over 2x squared minus 3. So now we can integrate this. The integral of 1 is just x, and the integral of our x over 2x squared minus 3, we're going to do a u substitution. So we'll say u is the denominator, du is going to be 4x dx, so dx will be du over 4x. So this will become the integral of x. We're going to call that denominator u, and the dx will be replaced by du over 4x. We'll account for that extra x. We can pull the 1/4 through and integrate our 1 over u du. So that's going to give us our x, and then plus our 1/4 natural log of u plus c, and then going back to our x's, we'll get x plus 1/4 natural log of the absolute value of 2x squared minus 3 plus c. Okay, let's see another example of that. You can again see the degree here of the numerator is greater than or equal to the degree of the denominator. So we are going to start by long dividing the denominator into the numerator. So we will say what times x is x squared, that's going to be x. We'll get x squared plus 3x. We'll subtract that, and so the x squareds will drop. 4x minus the 3x will be x, and we'll bring down the minus 2. And we repeat. So what times x is x, that's going to be 1. We'll put our x plus 3 down and subtract that quantity. So the x's drop out, and negative 2 minus 3 is going to be a negative 5. So we will take our remainder over what we divided by. So our integral will become the integral of x plus 1 minus 5 over x plus 3. So the integral of x is 1/2 x squared. The integral of 1 is x. And on the next integral, we are going to say u is the denominator, du is just dx. So we're going to get minus, we can pull that 5 out and have 1 over u du. So we know that part is going to be the natural log of the absolute value of u. And so our final answer is going to be 1/2 x squared plus x minus 5 natural log of, and we said our u was the x plus 3, and then our constant of integration. And there we have it. Okay. So these now are kind of abstract examples here. So we don't see really the functions, just kind of a symbolic representation of those. So the idea is you can conceptualize this like we have been. So we can say that the inside function is going to be this f of x right here. So we're going to say u is f of x, du, its derivative, is going to be f prime of x dx, and so dx will be du over f prime of x. So our integral is going to have that f prime of x that we started with. We're going to call that now e to the u, and the dx we will replace by du over f prime of x. And you can see the f prime of x's will cancel, and the integral now becomes e to the u du, which is our favorite integral. That's going to be e to the u plus c. And going back to what our substitution was, that's going to be e to the f of x plus c. Kind of different. In similar fashion, we can say u is the denominator function, f of x. That makes du, again, f prime of x dx, which, solving for dx, gets us du over f prime of x. That makes our integral, the f prime of x we had to start with. We can call the denominator u, and we replace the dx by du over f prime of x. That takes care of that extra f prime of x, and the integral becomes 1 over u du, which we know is going to be the natural log of the absolute value of u, and we can substitute back the f of x for our u. Again, we can say that u, the inside function, is f of x. Du is again going to be f prime of x dx, making dx du over f prime. That then becomes the integral of f prime over cosine squared of u, and the du will take care of that extra f prime of x. And if we remember, 1 over cosine squared u du, 1 over cosine squared is the same thing as secant squared of u, and we know that secant squared is the derivative of tangent. And so that will give us the tangent of f of x plus c. And one last one, u is again the inside function. Du is its derivative, making dx du over f prime of x. Our integral becomes the square root of u. The dx gets replaced by du over f prime of x. We get rid of that extra f prime, and in integral friendly form, we'll write it as u to the 1/2. So we'll add 1 to the exponent, multiply by its reciprocal, and then go back to our original, what we had substituted for, and we'll get 2/3 times f of x to the 3/2 plus c. Very good.